In this lesson, Unit 2, Lesson 3, titled Metals, Nonmetals, and Metalloids, our objective is that students will be able to infer whether an element is a metal, nonmetal, or metalloid given data about its physical and chemical properties. So the world is full of stuff, it's full of matter, and our goal over time has always been to make the best use of the matter around us to serve whatever function we need. So function a lot of times comes from the properties that the matter has. So since the beginning of time, humans have been examining the properties of matter and figuring out what function they can best serve. So for example, when cavemen had tools, they would use the properties of metals to benefit them because they could create knives, digging utensils, whatever that is used for. And people would use the properties of matter to make really nice swords, hard swords or soft swords or long-lasting swords, the malleability of the sword. Knives, we use them in cooking. I actually have a friend who goes to cooking school, and she said that she found out that softer knives are actually the more expensive ones because they contain more carbon, which, since they're softer, they're able to be sharpened, whereas if it's a harder knife, you actually can't sharpen it. So once it becomes dull, that's sort of it for the knife. So I thought that was interesting. Bridges, we learned to melt metals together to get the properties that best suit the function of a bridge. And arguably most importantly, we have field hockey sticks that used to be made out of wood, but now have carbon and Kevlar and silicone in them to give them the properties that they need. So you can have a harder field hockey stick, which will give you a better hit, or a softer field hockey stick for better receptions. So here's a few examples of how the properties of matter allow us to figure out its best function. Alright, so we are back to our friend, our best friend, the periodic table. The thing we're going to talk about now is how it is organized according to group number and period. So you'll notice here it says group or family, and there are two numbering systems. The one that we're going to use is this 1A system. So 1A refers to all the elements in this column. 2A refers to all the elements in that column, 3B, so on, all the way to 7A and 8A. You'll see this other numbering system underneath, and you'll see it goes from 1 to 18. That's a perfectly fine system. I don't use it in my class, so you'll see why I prefer it after we do a couple more lessons here. So if I tell you to find the elements in group 6A, you would come here, find 6A, and know I was talking about all the elements in this column. Now, just to complicate your lives a little bit, in addition to having a group number, they can also have family names. So the first family name that you need to be familiar with is, if I can get it here, yay. Okay, group 1A. The alkaline earth metals. Go ahead and write that down. The next one that you want to be familiar with is group 2A, the alkali metals. Now they have such similar names. My little trick, and it might work for you, is that I always remember that the longer name comes first. The next one that you need to be familiar with is groups 3B through 2B. So this little dip in the periodic table here are called the transition metals. I remember that because if you look, the periodic table to me kind of looks like a castle, and this area where it dips, the transition metals, kind of looks like it's transitioning from the left side to the right side. The next one that you need to know, next family name, is group 7A, the halogens. So those are right here. Next time you're in the light bulb aisle, you might notice that there are halogen light bulbs, and those are filled with halogen gases. The last one that we're going to talk about are the noble gases. That's in group 8A, and they're called the noble gases because nobles were like kings and queens that didn't interact with other people, and noble gases are gases that don't interact with other elements. We'll talk about that more later. The other thing we're going to talk about is the fact that on the periodic table, surprise, surprise, there are things called periods. So periods refer to the rows on the periodic table. The numbers here refer to the period number. You have 1 through 7. So the advantage of knowing group numbers, family names, and periods is that we can refer to them really quickly, and you could find an element on the periodic table similar to like a game of bingo. So we're going to try it here and see if you get it. I would like you to find me element that is in group 2A, period 5. So go ahead and find it. Pause me if you need to. The correct answer is strontium, because it's in group 2A and period 5, so it's where those two intersect. If you chose barium incorrectly, I know why you did that. You started with beryllium and you counted down 5, but notice that if you count down 5, you actually get into period 6. So you have to be aware that in certain groups there is no element in the first period here. Okay, or in this area, there's no elements in periods 2 or 3. So let's try one more. Find the element in the halogen group in period 3. Again, pause me if you need to. The correct answer is chlorine, because it's in the halogen group, which is 7A, and period 3, so again, I find where they intersect. So now we're going to talk about some particular properties that we're interested in. We talked about these a little bit in our first unit with properties of matter, but now we're learning that there are actually groups of elements, like metals and nonmetals, that share similar properties. So again, imagine going back in time and you're discovering these elements, you're trying to figure out how they're related. So what are you going to do? You're going to observe them and record some data. So after looking at enough elements, they said there's this group of elements called metals, and they always share these properties. And there's a group that we're going to call nonmetals, and they share all of these properties. And some of these are, if you picture a metal, you obviously know it's shiny, whereas nonmetals are dull. Hardness, they're very hard, whereas nonmetals are brittle. Recall that brittle means it's easily broken into parts, like when you hit it with a hammer. Malleability we also talked about. Remember, this is its property about being able to be hit into sheets with a hammer and not break. So malleable is actually the opposite of brittle. Ductility is actually the ability to be drawn into wires, which again sounds like an odd property to discuss, but think about how many elements or how many instances where we need materials to be drawn into wires. It's actually a very useful function. Conducting heat, conducting electricity, state of matter, and density. So we've talked about a lot of these things. So what you need to know is you need to know in particular that these are properties of metals and these are properties of nonmetals. Now you might be wondering, metalloids are not mentioned at all. So metalloids are somewhere in between metals and nonmetals, or they might be an element that have half the properties of metals and half the properties of nonmetals. Basically, if you examine an element and you can't really tell whether it fits in this category or this category because it either has some of this and some of this, or maybe it's somewhere in the middle, it means it's a metalloid. So what you did was you looked at elements, you recorded data about their properties, and so now it's going to be your job to try to classify them as a metal, nonmetal, or metalloid. So I want you to take a few minutes to go ahead right now and see if you can classify them as one of those 3 categories. So you're going to check your answer here in a minute to the elements that you just collected data on and classified. But But we're back to the periodic table here. Again, the beauty of the periodic table is it is so organized that you can actually determine whether an element is a metal, nonmetal, or metalloid by looking at its location on the periodic table. So the interesting thing here is that when I Googled an image for metals, nonmetals, or metalloids, I came up with a couple different options here. Now I can't seem to grab it, of course. So here was the first one, and you're going to notice that the yellow are the metalloids. So take note of that. And now we're going to bring in this next periodic table. And notice that it basically added this as a metalloid. The other periodic table didn't have AT as a metalloid. All the other ones, though, it did. The last one, periodic table I found, look at this. It has this element as a metalloid. So 3 different periodic tables, 3 different metalloids added each time to the periodic table. So can they all be right? Are they wrong? What's going on here? Well, the reality is that as we gather more data about different elements, we might have a better idea as to whether they're a metal or a nonmetal or a metalloid. But the truth is that because metalloids have properties of metals and nonmetals, it's sometimes hard to classify them as one or the other. So there is some gray area there where scientists might not agree on how to classify an element. For the sake of agreement, we are going to go ahead with this periodic table where the elements in blue are all the metals. You'll see here some common metals that you can remember: aluminum, copper, nickel, iron. All of those are metals. Even some that you might not think of as being metals are. Calcium is a metal. Sodium is a metal. The ones in yellow are the nonmetals. And notice that hydrogen here is sort of like an outlier. Hydrogen is a gas. So that's my way that I always remember that hydrogen is a nonmetal, because it's a gas. And gases, elements that are gases at room temperature are nonmetals. So that leaves the elements here in pink as our metalloids. So what you need to do is memorize these metalloids. And there is a trick here. I'm going to bring back our periodic table and show you the trick. The trick is to find the staircase here. This you will always have. See this bolded staircase? It's there to help you with the metalloids. So here's how I remember it. All the elements on the top of the staircase are metalloids. 1, 2, 3, 4, 5. And then I remember that the elements in the middle of the bottom are metalloids. Just GE and SB. That's it. Those are the 7 metalloids, and that's how I remember them. If you ever get the urge to tell me that this is a metalloid, stop and think, look at the element. It's aluminum. Aluminum is definitely a metal. Alright, so there you have it. You can now, just by looking at the periodic table, tell me whether an element is a metal, nonmetal, or metalloid. And you can also tell me some basic properties about the element, knowing that it's a metal, nonmetal, or metalloid. Further, you have uncovered another secret of the periodic table, that the elements on the periodic table are organized roughly by groups. You have the metals, the nonmetals, and the metalloids. One of my favorite quotes by one of my AP students last year was after our periodic table unit. She just sort of sat there looking at the periodic table and just went, oh, the periodic table it's full of secrets. And it really is, so the more we learn about it, the more you will be amazed by its organization and the secrets it has inside of it. Alright, so this sums up this lesson. Make sure that you meet all objectives for today, that you can identify an element based on its group number or family name and its period. Make sure that you can classify an element as a metal, nonmetal, or metalloid based on its physical properties. And finally, make sure that you can classify an element as a metal, nonmetal, or metalloid based only on its location on the periodic table, which remember requires you to find that staircase and know where those metalloids are.